This is Dylan Alexander for my submission of the Module 4 assignment, which is the student class representation. Right now, I'm in my PyCharm editor. This is my go-to IDE for anything Python related. I think that everything that it does related to linting, keeping you in accordance with PEP 8 standards for the Python programming language, it is the absolute best, in my opinion, at anything linting related, as well as indexing through your project. So in this case, we have a very small project. The root of my project directory is called CS4308, and inside of it I have a virtual environment and then like 5 different files. Inside of this virtual environment, it can get extremely bloated and just hard to work through, but the PyCharm editor, it does a really great job of indexing it, caching all of the data essentially that needs to be parsed through and activated for you to use the virtual environment. It does a great job of caching that and then saving it for later use, so it doesn't have to re-index every single time. So anyways, in this case, we have one student.py file, and this is a standalone file. I actually didn't even use any imports with this file, so it's a very bare bones student class representation. And our class representation has 3 class instance attributes denoted right here. Just the name, the student number, and the number of courses that the student is enrolled in. These instance attributes in this case are, again, very simple. It's a string, another string, and an integer. And of course, as Python classes grow in complexity, the comprehension of each class instance attribute grows significantly. So in Python, the language it's famous for people just compacting as many tuples inside of lists, inside of dictionaries as they possibly can. And that's when things really start to get hairy, because this is a dynamically typed language and there's no limit to how many different data types you can smash together inside of a data structure. So this is one of my pet peeves with Python, when people don't type it or try to add some sort of type hinting, just like I have here inside of the inline documentation for the code. It's so easy for people to just run through code and not even think twice about annotating their data types, because when the next programmer comes along, it's going to be 20 times harder for them to understand just what the previous person was doing, let alone fixing the problem that they were there to fix. Regardless, I'm getting off on a tangent, but the dunder method, this is what's going to initialize the student object. And again, it's literally just going to set whatever arguments you pass through the student initializer. It's going to set those values that you pass through to the student class. So this is the first iteration of setting variables to the student class, and we can do that later on in the program because we have getters and setters. So with these, we can actually change the value of the instance attribute for this class. So a great example, we name our student John Doe, but later we want to name them Jane Doe. We can do that because we, number one, can get the name, so we can understand, okay, what is the status of this current class instance attribute right now, and then later, if we want to change it, we can say, okay, now the self.name instance attribute, that's going to be a new name. So very straightforward. This same thing occurs for every single instance attribute that we have of this class. So we have a getter and setter for the name, the student number, and the number of courses. And the last piece of this, we have just display the student info. So this is a different than getting the student info, because when we display the student info, we are actually printing it to the console. We're doing essentially the same thing that the get name is doing, but the get name function, each one of these get student number, get number of courses, what they're doing is they're just returning the value of the class instance attribute. So you're just getting its current state. And that's what we're doing right here, but we're trying to be extremely, a good way to describe it is just very, very literal, if you will. You know, this is a very common practice in like .NET and like C# and Java. Python, you can absolutely do things in an object-oriented manner, but this is like sort of the most verbose way of doing it. So instead of just calling self.name, we can go through the practice of the getters and setters, like having individual methods to do this. And so, anyways, we have the if name equals main break inside this file, and this is simply where we just initialize a student with some very basic like data types of the John Smith 1 2 3 4 5 6 7, and then the number of classes they're going to be taking is 4. Then we're going to display the student info, print it to the console, and then after that happens, just reset the name of the student, and then also reset the number that the number of courses that the student is taking, and then of course display it one more time. So we'll be able to see like a very rigid implementation of the getters and setters. So what I'm going to do, I'm just going to run into my terminal. I'm going to cd into my project. And now what I'm going to do is I'm going to activate the virtual environment. Goodness, I cannot type today. So the virtual environment's activated, and now all I'm going to do is just run the Python file. And boom, this is it. This is a very straightforward program. We initialize a student with John Smith. All the other class instance attributes have been filled, and then we reset it. So, thank you.